Hi, everyone. Thanks for joining me. As you may have heard over email, I had a little slip up at the podium today, and I didn't get the screen recording, did not work. So I'm just going to be kind of running through the screen recording right now. I'm in my office, as you can see, and yeah, I'll just get these sort of explanations out to you. I know that without the video of the screen, they really don't make, I'm sure, any sense at all. So I will be turning myself off during the portion of the talk where we are addressing code. I have a couple of announcements about the last week of class, and from there we can just track on with class as normally. So I'll see you in one quick second. Hi, everyone. So we are looking at week 15, which is this week, and excitingly, it's the last week of class. So this week, we're going to sort of focus around interaction and interaction related to your assignment, code, function, interact. So we're going to be addressing techniques this week that can get you moved forward through that assignment. The examples that I'm going to be talking about this week for most of the class, Tuesday and Thursday, are these P5 examples. We'll get into 2 or 3 of them today. And then if we have time on Thursday, I will take some time to talk about some sort of advanced topics and other sort of things that are relevant to my advanced option users. So the finals week, as you can see, is a combination of really just the final. There's also a drop-dead deadline for all materials that you're submitting to the course, and that is midnight Thursday, May 12th. Obviously, as always, you know, if you have some extreme hardship or some situation that makes that not possible, please do let us know. Now, excuse me, the final exam is going to be sort of given in review over Canvas. I'm going to be posting a video rather than addressing it in class time on Thursday. So what I'm going to do is I'm going to post a video here, and I would estimate that I will have that video posted by Monday at the latest. I should be able to have it posted Friday or Saturday is what I'm kind of shooting for. And that will contain vital information about what will be on the final exam. So let's go ahead and get started with some of these interaction topics. I'm going to go ahead and get into these examples. And we're going to start with this first example, which is using map to convert mouse values. Now, I believe that example is right here. It is. So I'm going to be pausing the recording for just one quick second to undo some of the changes that I made during class. Okay, so we're back at the point where we started off with this code, and it should be sort of developing some of the things that I developed during lecture, and then I'll save the modified version so that you can get to it from this P5 examples. So those updates will just kind of be there. So when the code is sort of pared back a little bit, we have a couple things that are happening. It looks like right now we've got, let's go ahead and just pare it back so that we can kind of see what's happening without some of the rotation functions. And that'll make it super clear what's actually happening. So it looks like here we have a for loop. I told you that those would be kind of coming up several times, and they're really so fundamental. You'll see them in a lot of examples that I post. So let's just kind of maybe do a tiny little bit of a review of a for loop and how it works. So here we've got the declaration of our variable I, and we're starting that with a value of 0. And then we're testing I to be less than or equal to the value of height, which is 400, by the way. And then we're also adding 10 to I with each iteration. And so then down here, still inside the for loop, we call the ellipse. And when we call the ellipse, we're using I for the x and the y at the same time. So if I just plug in 0 for y, you'll see that if we plug in 0 for y, we're getting a straight line where only the x coordinate is changing. And vice versa, if we plug in 0 for x, we get a vertical line of objects where only the y coordinate is changing. So if both are changing at the same time, we get a diagonal line. So that sort of idea of using x and y simultaneously being modified to create a diagonal line should be in practice in a couple of the other examples on the course website. But anyway, it's a useful technique. So now we're sort of using mouse X, which is something, again, that we've used before in many sketches, but in this case we're going to use it maybe in a slightly more sophisticated way. And I can walk you through a couple different ways of using it. So right now we're going to apply a rotation value. So first I declared a variable for the rotation, and then here I go ahead and I just assign the rotation. I use the rotate function ahead of the call to ellipse. And what that does is it creates a sort of static rotation that, by the way, you may notice that that rotation is actually kind of getting added to every single time. Although if we print it out, let's just say, let's print out the value of rot here. And what I'm doing is I'm just kind of investigating to kind of unpack and show you a little bit about how what's called the transformation matrix works in P5. Do you need to know that it's called a transformation matrix? Probably not. But you can see here, it looks like when we print the value of rotation, that the value of rotation is not actually changing, it's remaining constant. And that sort of makes sense because we're not, this is commented out, we're not adding or subtracting from that value. So what we probably should think about here is maybe why then does this rotation look so different from this rotation? And the answer is inheritance and the transformation matrix. So I'm just going to take a couple of minutes to kind of show this and mention it to you. So here, if we go ahead and take push, and we declare push ahead of the rotation, and then we declare pop after what we want to rotate has been rotated, it's basically going to break that inheritance. So what it does is it forces this rotation to kind of only happen once, and then after that it resets what's called the transformation matrix back to 0. When you don't have push and pop, you get what is called inheritance, or even just this sort of like piling on of the matrix. So what happens is, let me show you that. It's basically taking the rotation value here, and then it's adding the rotation value from the previous run through the for loop each time it runs through the for loop. So you're getting this sort of accumulation of rotation. And it's not that the value of rotation has changed, it's actually just that the application of the rotation is sort of being done with the knowledge that it's starting from a new place every time. So it can be a little bit kind of tricky to wrap your brain around that. You could probably get through all of the examples for the course without sort of thinking about that, but it can be a really useful way to sort of apply transformations like rotation individually. Now, let me just show you quickly. I'm going to change this to a rectangle. And the reason is that it's actually quite difficult for us to sort of see how these are rotated other than where they appear on the XY plane. Obviously, an ellipse or a circle, if it's rotated 90 degrees, you can't tell the difference, right? Because it still looks like a circle. So let's give them that rectangular value, and then you can clearly see that here we have a rectangle that's exactly, 90 degrees sort of positioned to the XY plane. And by the time we get down here, we have something that has quite a bit of rotation on it. Certainly more than 0.005, right? Which you can see here in the first iteration, that 0.005, it's almost imperceptible. Okay, so that's just a tiny bit about push and pop. Now, let's get into the interactions. That's sort of why we're here today. So I've got a couple of things going on right now. I've got, it looks like a map function, and we had previously used the map function in relationship to color, but I think in this context, it's also a quite useful way of doing things. So I'm just going to give myself some tiny bit of real estate here in the screen, and what would happen, let's just say, sort of, this is the whole reasoning for why we're using map. I'm going to kind of build that up for a second. What would happen if we rotated by mouse X instead of this tiny rotation value of 0.005? Well, you know what? There's only one way to find out. Let's go ahead and, by the way, you might notice that I'm using a negative value. It's just because I like it better that way, and it aligns a little bit better with the mouse. Okay, so here's mouse X. I'm up here near 0, 0 right now, so that's like as small as you can get. And it pretty much instantly goes into like dance party mode, where it's just crazily accumulating large rotation numbers and basically giving us kind of a semi-random, values of rotation. And so that's a far cry from this sort of responsive thing that we had before when we were using the small number. So let's go ahead and see what that looks like again if we use rotate. Well, okay, so that's sort of like the level of rotation, like the quantity of rotation that I'm interested in, but I want it to be attached to mouse X. So how do I make that happen? Well, probably some quick and dirty ways of making it happen, like maybe taking rot and multiplying it by mouse X. But in order to really get it to be perfect, you're going to have to map the values of mouse X, and then you're going to have to map them onto the range that you actually want. So in this case, we're going to take the rotation value, we're going to use the map function, we're going to map mouse X, and we're going to map the mouse X from 0 to width. So you can move your mouse all the way across the screen from here to here. That's, by the way, that's 0 to 400. And we want to convert that range of numbers, 0 to 400, to negative and positive 0.05 is what I came up with. And we can go ahead and put in the 0.005 because it's what we're using now. And you can see when I hit go or whatever, that's kind of like a really slight amount of rotation. I think if I just had like a tiny bit more rotation, it would track with the mouse a little bit better. So by taking away that 0 there, I just am getting it to move a little bit more. There we go. Move. And as we can see, it's tracking pretty well to the mouse. It's not sort of ever going to track perfectly to the mouse, just based on this method, because we're asking it to move out into space as we sort of anchor it to the X coordinate. So, but in any case, I think you can see really clearly how that mapping has made a humongous difference. So just once again, this is what it looks like with mapping. And then if I just feed mouse X in here, you could see that I get a much more sort of chaotic, probably unintentional result that doesn't really give me that sort of feeling of actually maybe sort of tightly interacting with it. So the mouse X, mouse X and mouse Y are sort of like your two most easiest and probably most fundamental ways to get interaction going. But if you want to sort of make it a little bit slicker, definitely using the map function to sort of have it work within a very specific range will probably give you slightly better results. And so from here, I'm going to go ahead and just move on to our next sketch. So I'll go ahead and save this. Make sure it's in a decent state for y'all to look at. Okay. And then this sketch is kind of, there's a lot going on in this sketch. We'll probably spend most of the lecture period talking about this sketch. I'm probably, because, you know, I'm talking to y'all from my office right now, I may have to, you know, hit the button to sort of just pause to, you know, talk to people walking by. Hi, gotta go, bye. Okay, so, so yes, there may be the occasional interruption. So let's take a look at what we've got going on in this sketch. There's kind of a lot happening. I'm going to go ahead and just maybe comment some things out that we don't maybe need to think about right now. And I'm just going to comment out a bunch of stuff here. Just to kind of get it to a point where it's a little bit more manageable to kind of grok. If you don't know what grok means, grok is a science fiction word for understanding. Yes. Okay, so in any case, we have this sort of thing, and it does stuff, does some very basic things. So let's start with the mouse functions, and then we also have keyboard functions in here. So it looks like I have two mouse functions. I have a mouse clicked function, dun dun, and I also have a mouse dragged function. We're going to start with the mouse dragged function because it's definitely the easiest. It's the simplest, sort of good place to start. You may be asking yourself, hey, Meg, where do I find all of these functions? Of course, you could certainly avail yourself of the P5 reference. In the slides that I prepared for today, you may also notice, dun, 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 they're in here somewhere. You may also notice that, oh, come on. Hang on. Sorry, I think I have now broken past the wrath of the Google and UW sign-on. So in any case, as I was saying about the slides that I prepared, in the slides I went ahead and just gave you sort of a quick reference list of the most common mouse and keyboard functions, and linked them to the reference just to make it really simple and kind of streamlined for you if you're interested in any of those functions. So of course, you know, also you can just sort of look for them on the P5 website, but want to keep it manageable. So we're done with you. Go ahead and get rid of that guy. Okay, so here we're using the mouse dragged example in this example using mouse and keys to control fill. So it looks like, as I said before, we have two mouse functions, and then we also have a key pressed function in here. So we're going to talk about all of them. We're going to unpack it. We're going to talk about how it works, what you can do, you know, how you can use other code with these functions. I'm going to go ahead and just sort of run down the sketch and talk about what's there and what we can do with all of it. So as per usual, I created a bunch of variables to get started with, and we have variables called, one is called value, and it looks like that's a variable for controlling the fill. It also looks like we have a variable called click. That's my sort of preferred language for a variable that actually counts the number of clicks, not just whether you've clicked or not, which is what the function does. And then we also have a color in here for background, and we have some variables for the X and Y coordinate. Then it looks like we're creating a 400 by 400 canvas. And right away, I have gone ahead and positioned X and Y at width divided by 2, height divided by 2, which if you haven't seen this yet in my code, or maybe you haven't noticed it, that is the center of the screen. And why is it awesome to specify the center of the screen with width divided by 2, height divided by 2? I will tell you the answer is because that way if you change the size of the screen, which I'll do just here for a second, if you change the size of the screen, you still will end up with something. It looks like I have a problem from my commenting. Let me take a look at that real quickly. Okay. Got to be careful when you comment stuff out. Yeah, so then, you know, things basically line up when you make that larger screen. So you can see this is still positioned at the center of the screen. I'm going to go ahead and change this back to the smaller screen just because it's kind of easier to deal with it, because I don't have a whole lot of screen real estate here. But yeah, that sort of using the sort of system variable there helps your code become more flexible later on. So we're sort of using this coordinate at the center of the screen. Ooh, stuff's moving. That's not because of anything that we see on the screen right now. That's that mouse dragged function. And then within our draw function, we're doing, this is like the world's most simple draw function, actually. We just have a background with a value of BG. We have fill with the value of value. And then, of course, we draw the rectangle. And we draw it at XY, and then we give it also a dimension of half the screen. So let's go down here to the mouse dragged function. There's a couple of things that I want to show you about the mouse dragged function that applies to pretty much every other interaction function that you see. How do you know that it's an interaction function? Typically in P5 and most other languages, if something's a method or a function, it comes sort of stipulated in the reference with that empty parentheses. And so in this case, we're also actually creating a function by using the word function ahead of it. So this is really kind of the proper way to use one of these functions. So I get asked a lot, you can see this function is completely empty right now. Does that mean that it still works? Yes, it will still work, actually. It will return a value of true or false, whether the mouse is dragged or not. So in any case, we've obviously got our own sort of agenda here, our own sort of code that we want to run. But what I get asked a lot about these functions is, do these functions, mouse dragged, key pressed, all of these other different functions, how do you get things to happen in the draw function based on these functions? And that's a really great question. What would happen if I just drew like this rectangle inside this function? This is intentionally wrong, by the way. Nothing would happen. Absolutely nothing would happen. Maybe kind of hard to see, but nothing's happening. I'll make it an ellipse just to make double sure that nothing's happening. Definitely nothing happening. And so you can also see that my dragging has been sort of blocked because I commented this stuff out. So you cannot draw directly into these functions. Well, you might be saying, oh, that's kind of a drag, like literally mouse dragged. If I can't draw into them, what can I do? And the answer is really simple. You can change the value of a variable. So all of these interaction functions are really sort of inherently binary. In other words, is the mouse being dragged? Yes or no? Is it true that the mouse is being dragged? Or is it false? Those are the only two possible states. The mouse cannot be sort of halfway clicked. It can't be halfway dragged. So you're also always sort of playing with that idea of, you know, is this thing happening or is it not? Is it true or is it false? And so in this case, if the mouse is dragged, we're going ahead and we're setting X to mouse X and we're setting Y to mouse Y. I'll talk about that third line in a second here. So what happens when we go ahead and activate these three lines? Well, you can see that when these are activated now, X is equals wherever my mouse is, right? Now, how that gets into the draw function is right back here. Because X is a global variable, it's stipulated at the top. We can interface with it from setup and from draw. You can see we're just literally drawing the rectangle at X, Y, and we're shifting those coordinates by using the mouse dragged function. So that's how you impact what's going on in the draw function. You don't really do it directly by sort of drawing stuff in here. You do it somewhat indirectly by changing the value of things that may be referenced in the draw function. Okay, so now let's move on to clicks. Oh, except for one quick little thing. You'll see that I put return false at the end of all of these interaction statements. That's sort of like a maybe slightly superstitious practice on my behalf, but I believe in it. It basically makes sure that the function is done when it's done. So in other words, if I'm dragging and then I stop dragging, it doesn't it basically turns the state of mouse dragged to false when I'm done doing that. And that can help from sometimes like conflicts with other functions that have to do with interaction. So I would recommend doing it. It doesn't really cost you anything, and it just helps things move a little bit more smoothly. So you can see that I have that statement at the end of all of my sort of interaction functions, except for mouse clicked. I'll put it in here, just for consistency's sake. So let's take a second to talk about the clicks. I've got a couple of things going on here in the mouse clicked function. It looks like sort of straight out of the gate, I've got if click equals 1, value equals 255. So let me go ahead and restart the sketch. And what happens here is if I click it once, it turns white. So if click equals 1, then value equals 255. So you can see value is being used for the fill here in the draw function. And if I go ahead and look at click, what is click? Click is really just a placeholder. Click is a variable that I created to keep track of how many clicks we have. So like the mouse dragged function, the mouse clicked function, the only thing that it can really tell you is whether a mouse is being clicked or has recently been clicked or not. It's a sort of binary function. So if you want it to function in any other way, you have to kind of think about building that in. So if I wanted to really strip this down and get rid of click entirely, it'll work, except for that. And that extra. So yeah, it works just fine. But there's really nothing else that I can do. I'm kind of locked in at this point. If I click it again, what's going to happen? It's going to turn it white, right? So I have to kind of build in maybe some more complicated sort of routine for what's going to happen. And in order to do that, I need a variable. So I'm going to go ahead and have a variable named click for counting the clicks. That's up here. And I'm going to go ahead and when I activate the mouse clicked function, I'm going to add 1 to click. So this is basically my counter. So if I go ahead and just run this, I should be able to see on the console, oh cool, it's counting my clicks. There's 7, there's 8, there's 9, etc. Okay? So then I can kind of start maybe cooking with gas a tiny bit. So here is an if statement. If click is equal to 1, and don't forget you need the double equal sign within the test part of the if statement, then value is 255. So here it should actually turn off the white when we go on to the next. Well, it doesn't because we haven't told it to do anything else. If we wanted to, we could just put an else statement in there, this one in fact. So this else statement should say, okay, if click is equal to, sorry, I need to get rid of this. Got to bring my bracket back here. So this should basically say, okay, if it's other than 1, it goes to a value of 0. Now, you may also notice that in this else statement, it's also turning click back to 0. So let's go ahead and just make it so it doesn't do that. So now it's not going to be white unless it's been clicked exactly once. And so we can go ahead and maybe roll out these other else if statements. So these else if statements just create situations for other values of the click. And then it looks like when we're all done with that, make sure I have my little curly braces correct here. It looks like when we're all done with that, it's going to sort of rest on black. So here it's changing to different values, and then it stays on black forever. And you can see my count is going quite high now. It's like up to 20. I've clicked on it a lot. So what might be kind of useful is instead of letting the clicks go high, maybe we put some kind of limiter on the click so that when it gets to, let's say 5, so here it's testing for 4, and then if it goes 1 higher or does anything else, it turns the click back to 0. And that's going to allow for a little bit more flexibility and sort of this more kind of looping approach. So it will loop between these 5 states. Okay, so now I'm going to take a minute to walk you through this Keypress function. And the Keypress function has a couple of different things going on that we can kind of take a look at. So what is happening fundamentally when we press a key? Well, if this Keypress function is part of your code, then it will run this function every time you press any key. Now, might be a good time to sort of think about what is a key press? And for that matter, what is a mouse press? You may want to take a look at the list of functions because there's quite a bit of detail in what constitutes a mouse event. So, and that goes for key events as well. So in this case, mouse clicked is actually a combination of mouse pressed and mouse released. And then of course we've got double clicked, other mouse states. So it's the same with keys. It's just important to know that a key press is actually someone pressing down on a key and then lifting their finger off the key. That is what constitutes what this function is looking for. So if you press a key and you don't release it, you will not execute this function. Okay, so it looks like I've kind of highlighted one key press for us to start with. And within the context of this function, you can test for different keys. And so in this case, I'm using key code, which is a system variable. And I'm also using the code for the up arrow. And if you see down here, I've gone ahead and coded the up, down, left, right arrow. That's a pretty common convention in computing. In gaming is to use those 4 keys to kind of steer. So we can certainly, just stick with what works, and you do that. So what is sort of fundamentally happening here? Well, a couple of things you might want to take note of. One, when you're using the key code system variable here, you do need a triple equal sign, unlike the normal sort of approach to an if statement. And so here we're testing the key code to see if it's the up arrow. So also, by the way, for any interaction to work at all in P5, you need to click on the window in the web browser. So you have to kind of activate the window. So if I open up that, activate the window, and then use my up arrow, you can see that I'm pushing it down. And that's for a good reason. It looks like it adds 10 to the value of y, which is where I am drawing that rectangle to. So, okay, great. So, and then it looks like I'm also adding a little bit to the value. So the value is going up. Now, it just so happens that the value is already at 255, so we're not going to see that right at this moment. But I'll go ahead and keep that in as part of the code. So, looks like, whoops, printed that to the console. I'm going to go ahead and just code these other 3, or get them out into the code, these other 3 if statements. Notice that these are all else if statements. That's totally like, totally a matter of style. If you feel comfortable and it makes more sense for you to just use if statements and use more than one if statement, totally fine, totally fine. But I like the sort of else if syntax because it just kind of makes more sense to me when I write it out and when I look at it after the fact. So let me go ahead and play this. And so I've got my drag going. I'll make it nice and dark. And then here it's sort of coming up, getting darker, getting way dark, getting dark, dark, dark. It's disappeared. Looks like I've got it off the screen right now. Well, we could certainly prevent that from happening, but one thing that might be kind of useful right now, just because we can put the tone of the box to be the same as the background, it might be a good idea to have a stroke, just so we can make sure that we see it. So I'm just going to make a red stroke so there's no confusion there about where this thing is. And so yeah, now we can, oh, that's much better. We can still see it on the screen here. So in any case, these are all sort of arrow keys, and you can see that we're using the up, down, left, right, and we're also, because these are technically special keys, we're using the key code value. Now, what are not considered special keys that you would need to use all the special keys on the keyboard have to have the key code variable set. So what are some examples of keys that do not need that treatment? Well, probably the best example is any letter or number. And so let's go ahead and start with the key equals C. Okay, so here I've got a little if statement. It says if key equals C, print C. And it looks like that's going to sort of clear the background or turn the background white. So as promised, let's see if we can do this. And then I'm going to hit the C key. Nothing happened. Oh, that's so sad. Of course, I know why nothing happened. There's a little tiny lesson here. So why did nothing happen? Well, nothing happened because these keys are case sensitive. And so it's a very common practice in any coding related to interaction that when you're using keys that you test for both states of the key. So in this case, I'm testing for capital C and I'm also testing for lowercase c. And why do you do that? Mostly because you have no idea as a coder whether people have their caps lock on. And for that matter, most of your audience probably has no idea if they have their caps lock on or not. So in this case, it's going to test for both. And so if I run this and I just go for the lowercase c, it should allow me to type that in. Boom. And I got my little confirmation here in the console. So, so that's pretty much like the kind of big stuff of the sort of like how to use most of the interaction tools in processing. I think during lecture I did start to talk a little bit about sliders. And we went ahead and I made some sliders. There's an example where these sliders control RGB. And so I started to get in here and I wanted to make a slider that would rotate this box, this three-dimensional box, in a couple of different dimensions. So I promised the people in lecture that we would not sort of get through that. We didn't get through it in lecture, so I don't want to get my at-home crowd any further ahead than the folks in lecture. But it was my promise to the group of students in lecture that I would finish this. We ran out of time. And that when I go to start class on Thursday, that we would talk a little bit about how to use this slider to make this box spin. It's a pretty fundamental thing. And I do want to just draw your attention really quickly to one change we did make to the example sketch, and that is that we put it into WebGL mode, which enables this to be 3D. So there's a little bit of kind of tweaking that I have to do to kind of make this work and convert it to 3D. So I'm going to just make those changes off screen, and I can come in on Thursday with a nice fresh example of sliders moving stuff around other than color. If you're interested in using a slider to move color, though, that's all done, and it's ready here for you. So I guess I did this for lecture. You definitely have to instantiate the slider. So in this case, these are enumerated with commas because they're exactly the same. I could probably add this slider to that list if I wanted to. And then there are two things that you have to do to create the slider, and that is within the setup function, you need to use the create slider method, and then you have to position the slider. And so the create slider method is basically you're creating a range and then sort of number of a starting value. So in this case, the range is from 0 to 255, which makes total sense because it's for color. And then the starting value of 100 is pretty arbitrary, not super important. And then, of course, they're all sort of at 20 from the X, and then they sort of increase in value downward as we move forward. And then there's one more sort of important component of a slider that you need in order for stuff to happen, and that is this declaration of a constant in the draw function. This absolutely has to be in the draw function because it has to be accessible from the draw function. So I'll clean this up and we'll talk about this tomorrow, and then also tomorrow I'm going to show you a PowerPoint on how to sort of spot some of the more popular computer art algorithms in the wild as you go about your daily life. So have a wonderful evening, and I'll see you tomorrow, or maybe at some point in the ether. Okay, bye.